Welcome everybody to Algebra 2, Section 7.6, Properties of Logarithmic Functions. We're going to skip that first warm-up and go on to the second one. Log base 3 of x is equal to 4. And we're supposed to solve for x. So we're saying 3 to what power is x? So 3 to the 4th power is x. So we do the spiral and say, okay, 3 to the 4th power is x. And so, okay, 3 to the 4th, that's 81. And I would encourage you to try your next few on your own. On 3, we're saying x to the 5th power is 1024. Well, some guessing and checking can tell us that, hey, x would have to be 4 for that to work, because 4 to the 5th power would be 1024. And you could find that, not just guessing and checking, I should say, but by taking the 5th root. On 4, I want you to try 4 on your own. 6 to the x power is 216. Well, if you try and figure out, okay, well, 6 times what times what? 6 times itself how many times? X would have to be 3. So 6 cubed is 216. 5, 9 to the x power is 9 squared. Well, x would have to be 2 for it to be 9 to the squared is 9 squared for those exponents to match. All right, we're going to talk about some properties of logarithms today, and these can be very helpful as we try and solve logarithms going forward. So, product property saying log base b of x times y. So if you have two things being multiplied together there, it's really the same thing as log base b of x plus log base b of y. So it's like you can spread them out and you're actually adding. Quotient, if we're dividing x and y, it's like log base b of x minus log base b of y. And if we're taking it to an exponent, it's really like y times log base b of x. It's like as if the exponent could just be multiplied out in front. Now we're actually going to use these properties here in this table to expand these logs. So a condensed version of the log on the left, and sorry it says it's misspelled, but it's not, log base 3 of 4x squared. So how we would expand that is we'd say, okay, since 4 and x are multiplying, we're going to say log base 3 of 4 plus log base 3 of x squared. And that's using the product property there. But then we'll actually go further and say log base 3 of 4 plus 2 log base 3 of x, because the exponent using the power property can multiply down and front. And that, once again, will be helpful for us to solve things later. On the next one, we have division, so we're going to use the other one. The next one, the division one, log base, we assume it's 10, but you don't even have to write this in base if you don't want. Log of 5 minus, since we're subtracting, or since we're dividing using the quotient property, and the log base, or log base 10, so log of 2x. And then we can expand that further on the second one by saying log base 5 minus log base 2, or log of 2 is log base 10 of 2, plus the log of x. And we put that in parentheses because log base 5 was being divided by the 2x, so we have to subtract both log 2 and log of x. I said log base 5, I'm sorry, log of x 5. And then we're adding the log of 2 and log of x in the parentheses because they're multiplying together here. Now if you wanted to distribute the negative there and call it something like this, log of 5 minus log of 2 minus log of x, you definitely can, and that would be the same thing. Next, we'll do the natural log of 3 plus, and I'm going to do this in one step this time, 4 times the natural log of y, because it has a power, so I use the power and the product property in the same step, minus 5 times the natural log of x. So I didn't need to put anything in parentheses there because only one thing's being subtracted, and we can add in any order. So we just had to be careful with the parentheses on the last step unless you were to distribute the negative. Next one, log base 2 of 5xy. So we're going to have to put that base in there again. So log base 2 of 5 plus log base 2 of x plus log base 2 of y. And that's as far as we can go. I would encourage you to try the next one on your own. All right, so it'll be log base, let me zoom in there, log base 3 of 6 plus 4 times a log base 3 of y. Use both the power and the product rule there, minus minus 8 times the log base 3 of x. Once again, using the power to bring the 8 down in front, and then the quotient 1 there to use the subtraction. All right, I encourage you to try the next one on your own as well. That one, the natural log of 3 plus the natural log of y minus 5 times the natural log of x. Now, on the last 4 here, we're going the opposite direction. So we're going from expanded, and now we're going down to the condensed form by undoing those properties. So here, we have to think of it as if this 2 was out in front, how did it get there? Well, it would have gotten there by being the exponent originally. So we start out with natural log of 7 squared. And subtraction means it was being divided. And what was on the bottom? Well, 3 times the natural log of 4, that means it was natural log of 4 to the 3rd power. So it really was the natural log of 7 squared over 4 cubed. On the next one, log base 4, log base 4, not log base 10 of 4. So log of 4 plus 2 log of x, that'd be x squared, so times x squared, and then minus, and since these are both being subtracted, they're both on the bottom of the fraction. So 5 log y would be y to the 5th, and log z would be times z. So that would be the condensed form. Next, I would encourage you to try this one on your own. Log of 5, and I'm going to put parentheses around it because there's also a 2 cubed on the top that would need to multiply together, over 15. Use the subtraction there. Now, since those are actual numbers that we could multiply, we can go ahead and do that. And I guess we actually could have done it back on this other one earlier, the first natural log condensed one we did, where we could have done the natural log of 49, 7 squared, and we could have cubed 4 and gotten 64 if we wanted as well. So here we could do the same thing and say 5 times 2 times 2 times 2. So 5 times 2 cubed, 5 times 8 is 40 over 15. And that can reduce, so you'd reduce it to log of 8 over 3. And then go and try this next one on your own. So 3 log base 7 of 4 is really log base 7 of 4 to the 3rd, and then the minus, so divided, of log base 7 of 6, so we put 6 on the bottom. And once again, we can actually do 4 cubed, and that'll be log base 7 of 64 over 6, and 2 goes into both numbers. So you end up getting log base, I forgot the 7, the last one, log base 7 of 32 over 3. So that's it for today's section of 7.6. We were just expanding and condensing these logarithms using these properties we were learning today, the product, the quotient, and the power property.